D to D and Y, real world HVAC simplified. Now, in this video, I'm going to be showing you how to wire up a lockout relay, and I'm going to be going over how it works. All right, real time, real world, relay HVAC simplified, and I'm using the real world HVAC thermostat board today. All right, so before we get into the video, I want you guys to go ahead and subscribe if you hadn't subscribed, and smash that bell icon so when I upload videos like these, you get them right away. All right, so let's get into it. Okay, so now we have what's going on here. We have a lockout relay, or it's just a high potential or potential high resistance or high potential coil relay. Okay, so this is, you can call this a general purpose relay as well. And then we have an ICM. This is a lockout relay. I don't know if you guys have seen this one. It's a dedicated lockout relay. This one here, guys, not quite a dedicated lockout relay. You could use it for other purposes in your control circuit. However, these are great for using as a lockout relay simply because the very high resistance of their windings. Okay, and here we have a compressor contactor. Actually, this is not designated as a compressor contactor, but in this video, this is what it signifies. This would be your compressor contactor, but you can use this for anything, pumps, motors, etc. But in this video, this is your compressor contactor. All right, here you go. And then we have your low pressure switch. Okay, so low pressure switch. And then we have your high pressure switch. All right, we also have my nitrogen tank here that's providing pressures to simulate, real world condition when your system is low on refrigerant or going off on low pressure. So we have it connected here. You can see the hose goes right up to my gauges, and you can see currently we have about 75 psi, which is more than enough to make or satisfy this low pressure switch right here. Also in the circuit is a manual reset high pressure switch. Okay, and all this is wired up based on this schematic right here. All right, again, if you like this video, give it a thumbs up, and if you haven't subscribed yet to my channel, subscribe. I upload videos on a weekly basis. And last but not least, I have my jumpers, and these are magnetic because I'm going to use this to bypass the lockout relay. All right, to show you guys what happens when you have a cooling circuit with and without lockout. All right, and I'm just going to be going over all the wiring. Everything you see here is really simple. And what else? So you have transformer right here. This transformer, it provides 24 volts. All right, you can see black and red, and it's plugged in right here. So if I go ahead and push this, so now I have no power. Get this meter out of the way. So there is no power, and this whole circuit is dead. And if I hit this button right here, you can hear the compressor contactor. I just pulled it in. Let me go ahead and do it. Let me zoom out and do that again, just so you guys could see. All right, so if I shut this off, the contactor turns off. Okay, I'm gonna reset it. All right, so we got light, and our contactor is in. it's pulled in. All right, so let's get into the schematic. I'm going to explain to you what's going on here, how the lockout relay will work. Okay, so here's a schematic. Currently viewing it from my tablet/laptop. All right, but if you're wondering, here's the real world thermostat board. Okay, so here we have where the circuit begins, right here. This will be 24 volts hot coming from your thermostat, or in this current video, this 24 volts hot, it's not coming from a thermostat, it's just coming from directly from the transformer. So as you know, your 24 volts hot would go to R on your thermostat, and then when the thermostat calls for cooling, the circuit will close inside of the thermostat, and then Y would now have that same 24 volts hot signal, and that will continue down this wire right here and go around, and it's going to go here at these normally closed contacts. It's also going to go right here on the lockout relay coil, and you're going to have potential here. However, you won't have any flow. Okay, so basically what's going to happen, 24 volts hot coming here, it's going to go here, keep on going, it's going to bypass this right here, because here you have a normally closed contact, that's the lockout relay contact, it's normally closed, and C, and then you're going to have a continuous down the line, down the path, down the wire. We're going to have our cooling, our compressor safeties, which they usually be wired in series, which is your high pressure, low pressure, motor protector, free stats, whatever. But in the end, you'll connect them in series. You got multiple switches end to end, and they got to be normally closed under normal conditions. And so we continue down 24 volts, go down. Now we hit our contactor. Once we hit our contactor, our contactor coil is not broken, it's good. So if it's a good contactor, then what's going to happen is the power is going to pass right through and continue back into our transformer, our 24 volts common side of the transformer. Okay, so we got 24 volts hot, which comes from through the thermostat and comes out through the cooling signal or cooling coil, and goes around here and goes this way. Lockout relay contact, safeties, all the safeties are closed circuit all the way through. Our compressor is energized, our compressor contactor is energized, and our compressor is running. Now the reason why the power or the current wouldn't flow this way through the lockout relay coil, meanwhile everything over here is closed, the contact in this contact here, is these safeties are closed, is simply because the current will take the current tend to take the least part of resistance. So if you look here, this is just a continual wire, a straight wire. Remember, this is a contact which is closed, so hence there is no resistance. There is zero resistance across this closed contacts, and these are your compressor safeties. If they're all good and closed, there is zero resistance, so the current's going to fly right through and go to your compressor contactor coil. Now in the event this here becomes open, say your low pressure open or your high pressure open, now you have infinity or overload. There's no continuity across these contacts anymore. So what's going to end up happening is that now the current is flowing here. It has no choice because it hits infinity resistance or extremely high resistance here. So now this now is not looking good, right? This is going to be way lower than this infinity reading over here, because it's open set of contacts, open low pressure, open high pressure, open free stat, open motor protector, whatever you got in your cooling control circuit, series control circuit, open. So now current will flow this way through this lock relay coil, and now it goes this way, and then it passes through the compressor contactor coil and back to your common. Now, being that you have two loads in series, and this one here has the highest potential or resistance, it will occupy most of the volts, right? And also this relay, because of it's a high impedance relay or high resistance, it requires not as much voltage or power to activate it as the contactor here does, because the contactor is a lower impedance and lower resistance, so it requires more power to activate it. All right, so what ended up happening is now this here will activate and then open this contact here. So now what's going to happen, this is going to be your flow from your thermostat, go around through here, this way. Now once this relay is on, this contact, which is normally closed, becomes open. And once it's opened, and if you keep on calling for cooling, you got 24 volts coming around here, going this way, passing through your compressor contactor coil back to your common, and this relay keeps on being active. This contactor coil will not be, because the voltage is dropping across this coil here before it gets to here. And given that this one here requires less power to activate, there's a little bit of voltage left, because the voltage shares in series. You can see these are end to end. Goes in here, comes out here. Once this safety is open, end to end in series. The voltage is sharing just for a moment, and this here requires way less power to activate. It's a small springs. It's got huge springs, huge wires, huge coils. Needs way more power, and so that's how that works. All right. Now, the moment if you should close this safety switch right here, if you should pressure should go back up or go back down, and the safety switches becomes closed, then it wouldn't make no difference, because once this lockout relay coil is active, then this contact, normally closed contact, will become open. So it's just like, hence the reason, or hence the term lockout. It's going to be locked out until you remove potential, until you remove the call for cooling, or you remove the common. And then once the switch is reset, or the safety is reset, and the contacts becomes closed again, you send power, and we will take the least passive resistance all the way through. This will be omitted. That's it. Let's get back to the actual real stuff. All right. Okay, guys. So right now, it's business as our contactor, our compressor contactor, light. Our compressor contactor is active. Can you see that? It's in. It's pulled in. Okay. Because we got pressures. 75 psi, just about 25, 50, yeah, it's about 60 psi. So my low pressure switch is satisfied, so it's closed. High pressure switch is normally closed until you go above the operating pressures. This one is a manual reset, by the way. And so here we go. So like the schematic, let us go over schematic. So we're coming in here, and we're going to hit the 24 volts. Coming in here, we're going to hit the lock relay coil and the lock relay contacts first, right? So here is our 24 volts, right? This will be coming from your thermostat cooling signal, or Y. However, that is coming from your 24 volts hot. In this case, I have no thermostat hooked up. If you want to know how to hook up a thermostat, you can comment. I have videos on that, several videos on that. Okay, an airplane just went by. So where were we? So we're coming in from our 24 volts hot, which is representing Y signal, or from your thermostat. This is a red wire. We land right here on terminal 3, right? And terminal 3, as you can see right here, that's the relay coil, one end of the relay coil 3. Okay, so line 3, as we do on the join lockout relay coil, and then we shunt the same wire, goes over, and it lands on this right here is 5. Can you see it? 5. All right, that's 5. Okay, so we come in here, we land on the one side of the relay coil, and we also land on 5. And 5, if you go to the schematic here, you can see 5 is one side of the normally closed contact. Let me zoom in better. Okay, so there's 5, right? So we land on 3, and we landed on 5, right? There's a jumper, the wire jumps across here on the relay terminals. There's one terminal, another terminal, so which is coming from 24 volts in here and here. Okay, zoom back out. So again, here we go, and here we go. 24 volts are the 24 volts hot, are the Y call signal from thermostat, or cool call signal from thermostat. Next up, so we landed on one side of the normally closed contact, which is, this is say 5 right here. Okay, and over here would be terminal 6. Right, let's see. This is terminal 6. Here we go. Okay. So 6 close. These two is close. I guess 6 is the common. Doesn't really matter. Normally close contact. So we're good to go like that. So go on 6, and then from 6 we have our black wire here, right, which goes to compressor safeties, right? So this is 6 right here. So 5 over here, 6 over here is normally closed. That is how a normally closed contact is drawn, or relay contact is drawn this way, normally closed. Two dashes down and a slash across it. So we go, so from this is 6 on this side, that's 5 on that side, and then we go over here, we hit the compressor safeties, which is also normally closed. All right, if everything is okay, we have pressures is not too high, pressures is not too low, we're going to be closed. Okay, so we land on that side, which is the first switch, our safety switch, which is the high pressure switch. And so you see 6, and on the first side here, we come out of the high pressure switch. This switch is closed, by the way, unless it's stripped and our head is going to be open. And we come out, and then we splice, see the wire nut, into the blue wire, which is blue wire. Right, you see where it goes? Very straightforward, guys. We go into the low pressure switch. Go to the low pressure switch. If it's closed, we mean that everything is all right. We're passing power straight through. We come out of the low pressure switch, and you see where we go, right into the contactor. So once we pass through all our compressor safeties, we go right into the compressor contactor. But simultaneously, the other side of the relay, lockout relay coil, goes onto the compressor contactor, the same terminal as the wire leaving from the compressor safeties, right? Same terminal. So remember, this wire leaves the compressor safeties, as you can see, go right through. This is the other wire, which goes back to the other side of our lockout relay coil, which is going to be number 1. It says 1 right here, 1 right there. Okay, so that's that. Now let's make believe we have a leak. We're going to lose our refrigerant pressure. All right, so I'm going to open this right here. So our compressor is up, it's off, it's de-energized. Okay, we're at 0 psi. So I'm going to close this back, and the pressures should slowly build, and you will hear when the low pressure switch mix. Okay, let's start that over. Let's start that process over again. The pressures on the regulator wasn't set properly, so it was taking too long. So let's go ahead and I'm going to shut the power off here and reset my circuit, because you know the compressor is locked out right now. And I'm going to reset, shut this thing off. So we reset, power on. You can hear the compressor contactor energize, very firm banging. And we're going to go ahead and create a low pressure situation. All right, so the compressor contactor is disenergized or de-energized. You can see. Now we're going to go ahead, let our pressure went back up. You can hear the switch click. Let's do that again. Only this time. So you can hear the switch making. Let me go and close this right here. So you can get it a slower, better. You see? So the switch opens, but when we bring the pressures back up and the switch closes, the contactor still did not energize because it's locked out. All right, let's do that again. Okay, so that's how the lockout relay works, because the lockout relay is in the circuit right now. I'm going to check with my meter across here and here, and the coil will be active, right? Here and here is open. I should have potential across here and here, because these contacts, which is this contact right here, they are now open and this thing is locked out until you turn off the thermostat, cycle power to the unit. So let me go ahead and so we are reset because your pressures is back up. I go ahead and turn power off, put power back on, and right away you can hear the contactor pull in. All right, so that's how that works. Now if I were to go off on low pressure, okay, and then I try to reset while I'm still leaking, and pressures are still low. I'm gonna go ahead and turn this back on. I'm still locked out. Let me get the meter to test for you guys and you should see what's going on real time. So here we go. Voltage. So lockout relay call. So that's powered. Right? Got potential here, because this right now is open, and also this is opened. All right, and I'm gonna go ahead now and bring this back up, and you can hear that click from the switch it makes. So now this is closed, but because this is still opened, if I go across these right here, which is this right here, I'll get potential. Right, let's go. 24 volts right here. All right, see that? Right, that means these contacts are open, so there's potential across them. And I still have, even though my switch is satisfied, I'm still locked out. So here we go, we got potential across my lockout relay. Right, this is my relay coil. All right, now if I want to reset it, I simply cycle the power. I remove 24 volts, remove the coil from the thermostat, shut it off, and here we go. Okay, now I'm going to go ahead and bypass the lockout relay. There's a reason why I have these jumpers here. So I'm going to bypass it like so. And I'm gonna do so to bypass the lockout relay. I simply, now I'm gonna put across this contact here. All right. So watch what happens when I bypass, oops, when I bypass the lockout relay contacts. All right, so you can see we're bypassed, we're jumped. I'll go ahead and create a low pressure situation. Okay, so we're off on low pressure. Back up again. Now that's your compressor banging off and on, guys. Low pressure, pressure builds back up. Low pressure, pressure builds back up. Low pressure. So now you see the purpose of a lockout relay, right? Why a lockout relay is an important piece of a safety device. All right, so let's go ahead and look at this one here. Close that out. And if we take this jumper out of here, so this jumper basically just bypass this contact right here. Okay, so this lockout relay cannot take any effect on the circuit. Once this opens, because this is closed, it can't lock out because it won't interrupt power to the compressor contactor. But a jumper across here. Okay, and so now we are active. You get the idea. Questions, leave it in the comments. It's been 27 minutes. Now it's long, but there's lots of information here, guys. You won't find this anywhere else. So let's go ahead and wire this one up. All right. So this one here. Okay, so here you go. So this one here, safety switches, as you could see. This is it right here. I don't have a schematic for this, but it's self-explanatory. It said safety switches, and you can see this one here. You know, we're going into high pressure. Out of your high pressure, we're going to the low pressure. Out of your low pressure, we're going into your contactor. So it says safety switches. There you go. So one end of your safety switches goes right there, and then down here says common, or number one. You see, this is where you got your call from your thermostat, or Y, or Y1, or 24 volts hot coming in. You put that over here on the on your common, right? Boom. Okay. And then where it says contactor, you take that wire and you see, you put it on the same terminal where it comes out of the other end of your safeties. All right. Right. So you can see that where it says contactor, it goes on the other end that comes out of your safeties. So where it says safeties, this is one end of your safeties. It goes through one end. In your safeties, the safeties are in series. They're connected end to end. Out of these safeties, we go over here in the coil, on that same end, we bring it back over here, and where it says contactor, right? Connect compressor contactor, all right? And then obviously, again, the common, you're coming in with your 24 volts hot from your thermostat, right? Or your cooling signal. This is the same wire here. I just use a jumper to hit this with this demonstration. All right. What else? So let's demonstrate. Oh, this one right here, guys, the malfunction light. Once this lockout relay is activated, we will now have 24 volts on this terminal. So you can use an indicator light to let the client know or notify you that your system is locked out for whatever the reason is, higher pressure, low pressure, freeze protection. So if I go and, I don't know, I'm gonna do this with the camera. If I go here, and I can't do it, but just know that you will have 24 volts hot here, and back to your common. Oh, this is your common, by the way. 24 volts common on the black wire, see, by itself. And this is it right here. Okay, that part I left out of the equation, so you can see it now by itself is common. So when this lockout relay is stripped, you will have 24 volts from here, between here and your common. Okay, so let's demonstrate how this one works. I'm gonna go off. So we're locked out. We're back up. Nothing is happening because we're locked out. I'm gonna go ahead and shut my, you know what, I'll just remove. I'm removing this, I'm removing my cool signal. You know, cool is yellow, ironically. Cooling wire, put it back. Here we go, compressor is back on. All right, and if I were to do it again, go off on low pressure, will not turn on again until I reset because I'm locked out. Now I'm reset. Stop playing around. Why are you playing? All right, guys. So this is it for that. This is it for this video. You got questions? Leave in the comment section. I know it was a long video. It was a very long video, 30 minutes and running. But there's a great deal of information. Most people see these lockout relays. They don't know how it operates, you know, and they think it's magic. So I just break it down for you. You got questions? Ask it. I think after this video, you shouldn't have any questions. It should be straightforward. Once again, this particular one, this is a malfunction. I wish I could, let me do that for you guys. Hold on a second. If you're still here, you're very special. If you're still here, you're special. So you see I got my hands freed up right now. So I want to show you this malfunction output. All right. VAC. I got jumper, yellow jumper on the lead. And that goes to my 24 volts common, right? The black wire, right? Same black wire that goes down here, common, is 24 volts hot, 24 volts common, 24 volts hot, whatever, right? So let's go now. So if we go here, see what we got. All right, there's nothing. Now let's go and create a low pressure trick. Go and trigger our safeties, open our safeties. So now we're locked out. Okay, now let's go on this terminal now. Voila. Okay, that's it for this video, guys. See you in